Good morning, students. Happy Wednesday. Thanks for tuning into the geometry lesson. Same as usual, the Flipgrid is up there. Please go answer it. It's fun. I want to hear your answers. I would love it if you did that. If you are watching this video, you have already found the YouTube lesson. Now, please pause the video and answer this question in your notes. What is a circle? How would you define it in words? Don't just draw me a picture and be like, that's a circle. No, how would you define it in words? You had to describe it to somebody that had never seen a circle before. How would you do it? I'll tell you the official answer. I'll tell you the official definition of a circle later in these notes, but for now I want you to think about it. Okay, what we have for today. Our learning target and success criteria. The learning target says that you know the names of special segments and lines that intersect with circles. And the success criteria is that I can identify these special segments and lines. So hopefully you have noticed yesterday and the day before we completely wrapped up chapter 9. We did a chapter 9 test. So we are moving on to chapter 10. Which is all about goals. Hence why today, well, we'll talk about that in a minute. But here, I want you to see an overview of chapter 10 and what all we're going to do in chapter 10. We're going to look at lines and segments that intersect in a circle. That is what our learning target and success criteria are for today. So that's the first thing we're going to do. We're going to find arc measures. We're going to use chords. We are going to look at inscribed angles and polygons, angle relationships, segment relationships, circles in the coordinate plane, and so many other things. On the right over here, you can see the chapter learning target and the chapter success criteria. So you can see that by the end of this chapter, you should understand circles, and you should be able to identify lines and segments that intersect chords, solve problems using angle relationships in circles, solve problems using segment relationships in circles, and write and graph equations of circles. So that is what we are going to be doing for the next 3 weeks? Question mark? 4 weeks? I don't know. We'll have to see how long it takes us to get through all the material. So, to begin chapter 10, today we are talking about 10.1, lines and segments that intersect circles. The essential question for today is, what are the definitions of the lines and segments that intersect a circle? So this is the question we are aiming to answer today. There's going to be quite a bit of vocab today. That's basically all today is going to be, is a lot of vocab. So, pause the video, write this down, and then talk about it with me. So, this is the answer to our question in the entry task. How would you define a circle? And the way that we define a circle is as the set of all points in a plane that are equidistant from a given point called the center. So every point on the outside of this circle is the exact same distance away from the center. We usually name the center of the circle. We call it point P. So P is the center of this circle. So every point, every single point on the outside of this circle is the same distance away from that center. That's what's so special about a circle, and that's why we care about them so much. All right, next vocab word is the radius of a circle. So when we talk about all the points on the outside of a circle being the same distance away, well, what is that distance that all the points are away from the center? Well, it's the radius. And a radius is a segment whose endpoints are the center and any point on the circle. So one of the points is P, and the other point is anything on the outside of the circle. Now the radius always stays the same. We don't have a changing radius, otherwise we don't have a circle. So when we have a fixed radius, well yeah, all of those points, if my radius is 2 centimeters, every point on the outside of the circle has to be 2 centimeters away from Alright, more vocab. You might have heard of radius before. I'm pretty sure you've heard of circles before. But have you heard of a chord of a circle? I don't know. So, make sure that you are pausing the video and writing down all of these red boxes. They are important. So a chord of a circle is a segment whose endpoints are on a circle. And this is important. It is important. A chord is a segment. Let's even underline that. A chord is a segment whose endpoints are on the circle. So you see here how S and T are on the circle, and Q and R are on the circle. So a chord is any segment whose endpoints are on the circle. We could even draw another one. We could make this A, and we could make this B. AB is also a chord because it has endpoints on the circle. All right. Another one, the diameter of a circle. You have probably heard this before. The fancy name for it is a chord that contains the center of a circle, because we still need the endpoints to be on our circle. So, a diameter is just a segment from one side of the circle to the other side. Right? Other side, circles don't have sides. But we go through the center, perfectly through the center. So this diameter is actually 2 of the radiuses, the radii, plural of radius is radii, put together. So the official definition is a chord that contains the center of the circle. If your segment does not go through the center of your circle, it's not a diameter. Alright. I think these might be the last vocab words. So, a secant is a line that intersects a circle in 2 points. So this looks similar to a chord, but it is different, because remember, a chord was a segment. A secant is a line. Chord is a segment, secant is a line. They look very similar. The only thing that is different is that a chord has endpoints on the outside of the circle, and a secant is a line that intersects the circle in 2 places. Okay, a tangent. I know we just talked about tangent in chapter 9. That was the tangent ratio. This is something different. This is not a ratio. We're not looking at side lengths here. So the tangent from last chapter was in right triangles. Now we are talking about circle tangents. So make sure that you keep those separate in your mind. A tangent is a line in the plane of a circle. It's on the same plane as the circle, and it intersects the circle in exactly 1 point. And we call that point the point of tangency. So here, you can see B right here, and this whole line, the whole blue line, only touches that circle at this point B. So a secant touches a circle in 2 places, in 2 points. A tangent line only intersects at 1 point. Indeed. So we can talk about tangent rays, we can talk about tangent segments. They're all tangents. Okay, wonderful. That is all of our vocab for today. We only have 1 example today because there was so much vocab. I want to make sure that we have time for that vocab to sink into your brains. So we are just going to do 1 example. And that example is identifying special segments and lines. So they have given us different segments, rays, lines here, and we have to decide whether it is a radius, chord, diameter, secant, or tangent. Woo! We got to figure out which one of those it is. So let's start by looking at AC. Here is A and here is C, so we're looking at this right here. radius, chord, diameter, secant, or tangent. Well, this is from the center of the circle to the outside of the circle. So that is what we called a radius. A radius was a segment from the inside of the circle to a point on the outside of the circle. So I am confident that A is a radius. B is AB, so we have A here and B here. Let's see, AB is a segment with both its endpoints on the outside of the circle, so that is a chord. But we can get even more specific than that because it goes through the center of the circle. We had a special name for a chord that goes through the center of the circle, and that is a diameter. So it is a chord, but we can get even more specific and say that it is a diameter. Wonderful. Next, DE, the ray. DE, so that's talking about this right here. So, let's see, DE, it is a ray, kind of on the outside of the circle that only touches the circle at one point B. What did we call it when we only touched the circle in one place? Oh yeah, we called it a tangent. Tangent of a circle, not talking about right triangles. Tangent of a circle was a line, segment, ray, something that only touches the circle in one point. So C is definitely a tangent. All right, and now we're looking at line AE. Write it over. Line AE, so here's A, here's E, and we're looking at this whole line right. Well, let's see, I noticed that it intersects the circle at two places. So a chord intersects a circle at two places. No, a chord has two endpoints on the outside of a circle. But this isn't a line segment. It doesn't have endpoints. This is a line that goes through the circle and intersects it at two places. So that is what we call a secant. So D, the line AE, is a secant line. Wonderful. All right, let's check and make sure that we were right. A is a radius, AB is a diameter, DE is a tangent ray, AE is a secant. Beautiful. Beautiful, so we were right. Okay. Like I said, I only have one example for you today because I want to make sure that those definitions can seep into your mind. So if you're like, wow, this lesson went really fast, okay, go back and make sure that you have all of those definitions in your head because we're going to use them tomorrow, and we're going to be using them throughout Chapter 10. So please, please, please make sure that those definitions make sense. And hey, if the definitions don't make sense, please tune into my live stream every weekday from 12 to 2 p.m. and we can answer any of those questions that you have. Your homework. Remember that I can't grade this until we come back or until they officially tell us that we can move on with new material. So remember that this is not required right now, but it will help you get ahead. So if you're watching this, good job. Good for you. Proud of you. You only have 6 questions. You only have 6 questions on your homework, and it is all about using the diagram to name radii, name chords, name diameters. Remember that radii is the plural of radius. So 2 radiuses radii. Instead of saying radiuses, we say radii. Okay, awesome. There is your homework. And our launch for today comes from William James. And it says, it is our attitude at the beginning of a difficult task which, more than anything else, will affect its successful outcome. That's a fancy way of saying your attitude at the beginning of doing something really hard is what's going to determine whether you do it or not. So if you set out to do something really hard, maybe eventually you want to be able to do 50 push-ups in a row without stopping. That's a pretty difficult task. And if at the beginning of starting that journey, you're like, wow, this is so hard, I'm never going to be able to do it. That's defeating yourself before you even start. So, if you take the attitude of, this is going to be hard, but I'm going to work at it every day, and it'll become easier and easier the more I work at it, that's going to set you up for more success than saying, oh, this is hard, I don't really want to do it, but I don't know. So, your attitude at the beginning of the task is what is going to determine how successful you are at that task. So that is my launch for you. Take it with you as you go throughout your day. I hope you have a wonderful rest of your day. Thanks for being here. Thanks for watching. Bye.